Hello, everyone. How are we doing today? How is everything going? Yes. We are back. We are back. We are back. We are back. And of course, as you know, this is the Azure um, Azure community, the cloud and infrastructure community. And as you know, we try to update you on the various changes happening in the infra end and also on the Kubernetes end. Today, we are going to be speaking more on the infra end. And of course, for me to or for us to host this session today, I'm not only by myself, or maybe let me introduce myself first in case you don't know who I am. My name is Promise Uche Unwachku. I'm a Microsoft MVP for AI, Microsoft Foundry, and Azure, right? Yes, but of course, today I'm not only by myself. I have our hosts, or I would say our group of hosts in the house, and I'll be calling on them also to do a quick introduction, and then before we proceed on the series. So, quick one. Let me welcome Chidebere Ugo to the stage. Hello, Chidebere. How you doing? You're muted, Chidebere. You're muted, Chidebere.
Yes, can you hear me?
Yes, I can hear
Can you hear
you
me?
now. How are you doing?
Yeah, I'm good. Thank you. Thank you, Promise, for
And
this
how?
awesome introduction. My name is Chidebere, the MVP
Oh,
Azure Infrastructure as a Code. Today, we'll be having a section regarding AVM. Stay tuned.
awesome. Thank you very much for that, Chidebere. And of course, we also have another MVP in the house. Hello, Ian Achochuku. How are you doing today?
Hello, everyone. It
Awesome.
feels good to be back here in the series. Yeah,
Um,
having on that great learning experience with you guys. Love of IaC as always, natural here in the house. MVP, IaC, AKS. Yeah, I'm happy to be here and we're gonna have some fun here. Thank you.
Awesome. Thank you very much for that, Ian Acho and Chidebere. All right. I'll be proceeding to start up the session for today. And as you all know, we'll be looking at an interesting topic today. And of course, I'm going to have helping with this particular series. Our MVPs, Ian Acho and Chidebere, will also be taking various sections of this session today. For today's topic, we'll be talking on not other than introduction to Azure Verified Modules. As you all know, Azure Verified Modules are modules that have been tested. All of the various testings you can think of have been done on the modules, and these modules are sure to give you what they are designed for. All right. Okay. Let me proceed on what really is the Azure Verified Modules. For those of you who are wondering, oh, really, there is something called Azure Verified Modules? Yes, actually, there's something called Azure Verified Modules. And of course, these modules have been vetted, verified by various Microsoft professionals, and indeed, they give you what they are meant to do. But of course, they are none other than an open source initiative that is provided and provides a curated library of reusable, pre-tested IaC components for Azure. Right. So it's the fact that the modules are done in such a way that you can always reuse the modules. It's not a one-time use. You can use it to create multiple resources without having to change much, right? All you just need to replace are the variables, right? And these modules or these verified modules are also available in Bicep and Terraform. So with Bicep and Terraform, you can get this Azure Verified modules for almost every resource you can think of on Azure. Almost every resource you can think of on Azure. Now, As you can see here, it says the modules are reviewed against strict design principles, tested automatically and maintained by Microsoft and the community. They are published to public registries and ready to consume anytime, right? So, as you can see, we provided you with the Bicep public registry, same as the Terraform registry. So, like I mentioned here, these modules have been they were created with strict design principles. A lot of testing has been done on them to ensure that they are able to produce right what they are designed for, and of course they are maintained by Microsoft and also the community, right? So by meaning the community means you can actually make suggestions as to what you want to see in these models. Probably you have an idea, you feel that okay, it's possible to contribute towards the development of a model. It means that your suggestions are very well welcome. You can raise a PRO, and of course the admin will go through your changes and make the necessary additions where possible. Right. Okay. Let's proceed. Um, Now, of course, you wondering itself, what problems does the Azure verified model solve? What problems do they solve? Of course, you will know that no one will come in and put a lot of time into ensuring that everything is working fine if it's not providing a solution to a problem, right? So, of course, the three major, I would say, problems it's solving is inconsistent standards. So, you want to ensure that when you want to deploy anything in Azure, you are following a consistent standard, right? So you see here it says different teams configure the same resource, like a storage account, in widely different ways, right? So now to avoid such issues, that's where the Azure Verified Modules come into play. Also, there's what they call the module hell, right? Which is generally the difficulties that come with maintaining your own internal module libraries. It's practically a full-time job. You need to consider versioning, testing, documentation, updates, all of those stress that comes with maintaining a module. It's really, really tedious, right? But Microsoft has brought about this idea of the verified module to ensure they take the stress off your hands. And lastly, we talk about the vision, right? The vision is the idea behind the Azure Verified Modules. And in this case, it's a single source of truth, one verified shared library of modules for the entire organization. So we call it a single source of truth because it's produced by the product owners themselves, right? The product owners who really built the product, we are definitely in the best position to tell you how the product should behave, right? And what steps you should put in place to ensure your models give you exactly what you're looking for, right? So three main problems that the Azure Verified Module solve is what? Inconsistent standards, module hell, and of course the vision, right? Once you understand how Azure Verified Modules are solving this problem, then you can understand why it was created. So it was created for these major reasons. So here are some of the problems we've spoken about. And of course, we'll be moving to the next step, the module hierarchy. And to help with this, I think I'll be calling on Ihe and Chuku to proceed with this particular session. Hello, Ihe and are you there?
Yes, I'm here. Thank you for that awesome introduction and
All
walking through the modules. Yeah,
right.
so yeah, to take you straight to the module hierarchy. No, the way Azure Verified Modules, try to have its own classes. I'll say module classes, module hierarchy. It kind of helps to like have different hierarchy or classes for its own deployment and how it manages its module. So the first one here is the resource module. Is a class, right? And if you follow along with the name, okay, you kind of understand that it helps to kind of deploys a single resource, all right? So resource module are building blocks for deploying just one single Azure resource. Say, for instance, Azure storage account, Azure virtual machine, Azure networks, and things like that. So have in mind is one resource per deployment, right? Then we have the patterns module. It's taking it a little bit a step further, right? It kind of combines different resources, kind of, right? So having like a group bundle of module together as a single pattern, all right? So you might want to consider multiple resource collections, like having the likes of web app with say a database and probably some networking resource, all right, working as one single pattern, all right? So it kind of helps to coagulate a lot of resources, forming one pattern of module. And finally, we have the utility module. See this more of like providing shared logic, like naming system, outback role assignments, telemetry, usually things behind the scene, kind of, right? So this seats this way, it's handles utility to share logics, right? Maybe an organization have a kind of naming pattern they want to follow or standards or things like that. They're going to be having this utility module kind of class of the modules, right? So a simple way to try to remember all of this is for a single resource, we are looking at a resource module. A pattern is for like a full solution, right? And put it simple in terms of utility, we are looking at for shared logic. So we'll go to the next slide. Promise, could you help me change the slide, please? Yes. So here we have the verified standard. Now, part of what Promise tried to kind of introduce us to is the chaos of managing modules within IaCs. Carefully looking at Terraform and Biceps as our main core here. Okay, so what's the word of standards? Okay, we are looking at what automated testing, making sure that we have read our codes, gone through different standards, industrial standards, linting, verification, unit tests, just to make sure that these modules, okay, are verifiable, they are tested, all right, they have passed all the criteria that we expect for a standard module, right? So also we are looking at Azure review. This more of like having peer reviews and following different like say standards or patterns, really, where we are making sure that these engineers with a lot of experience, talking about the Microsoft engineers, they have very strict way of reviewing codes and standard interface standard, right? So they're taking their experiences, they're pouring that into the code review, making sure that they are not absolutely following the industrial standards. All right, and the next point we have here is the design principle. Of course, there are quite a number of design principles we have for securing application deployment, right? Things more of like cloud adoption framework and other kind of standards that helps to define correct landing zones. All right. So these design patterns are carefully followed, and that will take us to the very next one, which is secure by default. Because of the standards and things we have in place, there are some agreeable, known, not secured configurations that wouldn't be part of our modules. Things like imagine having a public IP address or public access. That's definitely disabled by default. Of course, we're looking at also having a TLS, having our certificates secured and all of those encryption in place. These are enforced by default. So we see this as secured by default. So from the very first day of using your Azure Verified module, you can be rest assured you have a standard Warecraft module managing your resource deployment. Okay, so now we'll just go to the last slide, promise, please. Um, Next slide, please. Yes. So here we have the design principle. And this kind of gives us the criteria upon which, after carefully reviewing by Microsoft internal engineers, professionals, they have worked with this general known principle, courtesy of the problem we already tried to introduce. Like we always have it in, it's common events, right, where you see a lot of code duplication, copying things here and there, and sometimes when you look at the code collection, you can't just, you just wonder who did all of these, right? It's not uncommon learning different IaC and getting better, improving yourself, but the principle here is dry, do not repeat yourself. All right. Dry and config as a code. All right. So as much as we don't want to have any form of code duplication. All right. So we are following this principle that says first dry, don't repeat yourself. Everything is defined once and we use all the time. All right. So no duplication. So we'll go to the very next point here. So we have consistent interface. Things like name, location, tags are standard across all modules, right? So if you define this interface, you can apply everywhere as well as standards in across all the modules. So this is one of the design principle we put in place to kind of carefully craft, the Azure verified module, which is what makes them a verifiable module. Then the next point here is idempotencies. Okay, is the common principle of IaC in general, which is if you have the same configuration, you have the same Bicep Terraform module being called at all times, we expect to have the same result at all the times. All right. So this is one of the very core of handling things of such scenarios. So again, we have the very next one online here, which is, of course, we come to that same point, secured by default. All right. Like I mentioned before, all the best practices, all right, Azure best practices for security, all the best practices, making sure your back ends are not exposed and things like that. This is the major core considered during the design of this module. So those unsecured configurations are not part of the module. Only secured ones are applied across the module. So this principle helps us to enforce consistency and of course reliability at a scale. All right. So yeah, I'm gonna have to stop here and allow my very good colleague Chidi Ebere to kind of walk us through a simple hello world demo like I would like to use. And Chidi, could you continue from here, please?
Okay, thank you, Nacho. Thank you, Promise, for this awesome introduction and explanation of this so far. So I'll be sharing my screen from here, and then I'll give us a quick code snippet of what we're about to do, and then we dive into the hands-on experience. So please let me know when you can see my screen. Oh, yeah. Okay. Yeah, please let me know when you can see my screen. Can anyone see my screen now? Hello.
Yes, we can see your screen.
Okay. So just in continuation to where my colleague Nacho stopped, so I'll be giving us a walkthrough of how Azure Verified Module works compared to the traditional method of deploying infrastructures. So on my screen here is a raw code snippet for Terraform and then that of Azure Verified Modules. So from the first part, which is the raw Terraform code, you identify that first you have to write the resource and call Azure resource group and then give it a name and then add other variables or parameters like the name, location, the tag, and the rest. However, with Azure Verified Modules, you are going to call a module that is on the second line where you see source. Source is the module. And unlike the traditional way of deploying Terraform modules before, where you have to write your modules to deploy series of infrastructures, you want something like virtual machine, resource group, AKS, and the rest. And then on your main.tf, then you have to code those individual modules. Here, you don't have to write those modules because the modules has been written. So by Microsoft expert, yours is just to call each particular module by referencing the source. So like here, you can see on my screen, the source here is Azure Verified Modules, resource and resource group. So this follows a particular naming convention, specifying Azure Verified Modules, the rest specifying the resource. Just like my colleague Nacho explained that you have resource modules, we have pattern modules, and we have utility modules. So within this interface, you see a resource that we are trying to deploy a resource modules. If it is a pattern module, the RES should change to pattern module. That shows what you are actually the particular module that you're actually using. Then on the second part is where you specify your version and then the resource unique resource group name, location, and the rest. So going to the next slide, you will see the same similar comparison between a Bicep, deploying a resource group using a Bicep, and then using AVM as well to deploy that. So on this, you specify the resource group and then the names and other parameters that are in it. Then on on the AVM side of it, you need to make reference to the module. So which on the first line you'll be able to see module RG, which is resource group, and then BR. The BR specifies that this particular module is stored in Bicep registry. And then from that Bicep registry, the host name is br.microsoft mrc.microsoft.com, which is the Azure Container Registry that is hosting that. Then you can also specify some other parameters, which is optional. So parameters like name, the prefix for your name, the resource group, location, and the rest. However, if these optional parameters are not specified, Azure Verified Modules follow a standard naming convention, as you can see on the first line where AVM RS resource group is stated. That's following Azure Verified Module resource and then resource group. Yeah, on this slide is another more detailed example of deploying a storage account, comparing that with a raw Terraform script, which has like 80 lines, and then a verified module to deploy the same storage account with 12 lines. So the instead of writing multiple lines of code, which in some scenarios, depending on the level of expertise of the engineer writing the Terraform template, so there are some things that are necessary that in some scenarios that are omitted, something like the TLS, the security version, the network configuration, and the rest. But with Azure Verified Module, you don't have to bother with all those configurations, because those best practice configurations have been taken care of by Microsoft, and then is already in the module that you are calling. So once you call the module, the only thing you have to do is just to specify a few optional few parameters like the name and the location where you want to deploy your resource. So, lastly, on this part here, before we dive into the hands-on, is how pattern module actually works. Because as my colleague explained, the pattern module, the resource module, and the utility module. So, this resource module actually is for just a single resource, while the pattern module is a bit more complex because it's composed of multiple resource modules together to implement a complete solution. And then how that works is, within a pattern module, you specify the source version, which is the pattern, the PTN, like the previous slide where I explained the resource on. Then you have to specify the PTN, which shows that you are calling a pattern module. Then you pass your parameters like the name prefix, the SKUs, and the rest, which some of those parameters are optional because they have been taken care of by the module itself. And then the next stage is to deploy. So from this now, I'll be going straight into hands-on experience, trying to deploy a simple resource group. So let me know if you can still see my screen.
Yes, we can actually proceed.
Yes, on the interface of Visual Studio Code, right? Which of my screens can you
Yeah,
see the Visual Studio Code? Am I
Visual-
correct?
yes,
Okay,
yes.
good. So just a quick one, as all know, to deploy a Terraform module using the traditional method, as I explained before, you have to create a folder, for instance, and name it module, and then you start to create different infrastructures inside it, like the resource group, virtual machine, and the rest. And then on your main.tf, we have to call those modules. But here using Azure Verified Modules, so what we just have to do is to call this particular module uh, from the registry, and then specify some optional uh, uh, parameters like the name, the locations, and then you can specify the tags as well. So having done this simple setup, so we just have to do AZ login. That's to authenticate to the Azure portal, and then we'll try this out and see how it works. Okay, that's done. Okay, I will do Terraform in it. Okay. Okay, from this output, you see what the module the resource group is going to deploy. So we have first is the resource group itself and then the telemetry. As you can see on the code I shared, I did not specify any telemetry also, but however, due to the Azure Verified module has handled a lot of stuff from the developer side, so some other dependencies that are necessary are included in that. So the next stage is to apply this and it will deploy to Azure portal. Okay, good. Yeah, once this is done, we'll check that on the Azure portal to confirm. Okay, that's fine. Then on the Azure portal, I'm going to check resource group to confirm if okay. As you can see, this is resource group Azure Verified Module Demo 001, which we've just deployed. Because there's no other thing that will deploy with us, so the resource group is basically empty. So this is just a simple demo on how to kickstart your Azure Verified Module journey. So we deployed this using a manual method, but on subsequent event that we are hosting, when we dive deep into other more complex infrastructures, then we'll be able to deploy that using a CI/CD pipeline, and then we'll also explain on how you can set up your own CI/CD pipeline. And then if you have questions, you can also reach out. So at this stage, I'll be handing over to my colleague Promise to do a quick wrap up on this and then entertain questions from our viewers. Thank you.
Awesome. Thank you very much for that, Chidebere. I would say that has been really, really quite awesome. Thank you, thank you, thank you. So, guys, yes, you have learned from one of the best or from the best people you can have in this community on Azure Verified Modules. So if you have any questions, don't hesitate to reach out to us. And also, you can see just right on the screen, you can see our community handle scrolling. So in case you are not following us on our social media channels, I would say please do so. Right. So for our LinkedIn, you can see it's Azure infrastructure DevOps support community. For our YouTube page, it is Azure infra DevOps support com. And for our meetup, it is Azure Infrastructure and DevOps Support Community. So if you are not following us on our social media pages, please go ahead and do so. And of course, you can also send in questions on the chat. We are also monitoring the chat for questions, and I see Abby Abby Ude. Yeah, he asked what we were studying today, and of course, we replied him that we were talking about Azure Verified Modules. So I'm not getting any questions. I'm not seeing any feedback from anyone. So I believe sure we can round up the session for today here. But maybe before I do that, I will just call on MVP Ian Acho and MVP Chidebere in case they have any last words before we close the session today. So who would want to come up first? Okay, MVP Ian Acho, do you have any last words for us before we close the session for today?
Yeah, thank you for everyone for joining the session. We do appreciate your time, and also wanted to use this opportunity to say we as well entertain bringing up interesting topics. If you have anything you think might be beneficiary for the community, feel free to share these topics with us, or probably any challenging stuff you did like us to talk about. We are more than open to have such discussions. just reply that on the chat and we'll follow up with it. Thank you.
Thank you very much, MVP here, Nacho. MVP Chidebere, do you have any last words before we round up today's session?
Yes, I want to appreciate our viewers, those that were able to join us. So I do like to encourage you to follow our social media handles or the YouTubes. We entertain questions from there as well, and then you'll be up to date on our subsequent events. Where we'll be there. This is just a start of this series, Azure Verified Modules, and then as we progress, we'll dive into other more complex scenarios. Thank you.
Awesome. Thank you very much, MVP Chidebere. At this point in time, I would like to thank you all for staying tuned for this very session. Of course, please don't hesitate to share this session to those of your friends who are still wondering what is Azure Verified Modules. I hope we've been able to give some insight into what really Azure Verified Modules are all about. And we look forward to hearing your feedbacks regarding this series we have just started today. At this point in time, I would like to say thank you very much and goodbye.
Yeah. Goodbye.
Bye bye all.
Bye bye.